So we're back with example 3 on the back of the notes booklet for graphing logarithmic functions with transformations. And like we did in examples 1 and 2, we're going to start by identifying the a, the b, the c, the h, and the k. So a is the coefficient in front of the log function. That is a -1. Then our b is the base of the log, which is a +4. The c is the coefficient on the x in the argument of the log function, and so our c is a 2. The h is acting on the x, so the h, if there was one, would be grouped in parentheses with the x in the argument of the function. Since there are no parentheses here, the argument of this log base 4 function is just the quantity 2x. It does not include the -1, right? That -1 is the constant, so the -1 is the k. Okay, the h is a 0 because there's nothing acting on the x inside of the function. So it might be easier to see that if we write this function out in expanded form, looking at each of our transformations. So -1 is times the log base 4, and then our c is 2 times the quantity x minus h, which is 0, and then plus the k, which is a -1. So that hopefully helps you see that the x minus 0 is x, 2 times x is the 2x, which is the argument of this log base 4, and the -1 is the k, because that's the constant outside of the function. So the asymptote comes from that h, and since our h is 0, the vertical asymptote is the y-axis, just like the parent graph. So we put a dashed line along the line x equals 0. Okay, then we're going to identify the anchor points of the parent graph, log base 4 of x, and those come from the base, the b, which is 4. So 1, 0, b, 1 would be 4, 1, and then the reciprocal of b, -1. And reciprocal of 4 is 1/4. Then we're going to take care of this reflection in the x-axis by multiplying each of these y values of our anchor points by the a, which is -1. So we'll have the point 1, 0, 4, -1, and 1/4, +1, because each of our y values is going to change to the opposite sign. Okay, next we're going to divide the x coordinate by the c, which is 2. That's a horizontal shrink, so that's going to give us 1/2, 0, and then 4 divided by 2 is 2, -1, and 1/4 divided by 2 is 1/8, +1. Okay, then we're going to add h, which is 0, to each of the x's. Adding 0 to any number isn't going to change that number, so we can skip over that transformation. And then our vertical translation is down 1 unit, so we're adding k equals -1 to each of these y coordinates. So the x's are all going to stay the same, and then the y's all decrease by 1. So -1, -2, and 0. So now we can go ahead and graph those points on our coordinate plane. So 1/2, -1, then 2, -2, 1/8, 0 is really close to that asymptote. And then we're going through the extra guide point that was given on the graph 8, -3. So we come along that vertical asymptote, bend through those transformed points, and that would be the graph of our logarithm. Okay, the domain is starting at 0 and headed to +infinity. The range is all real numbers.